morning, students. I'm Dr. I'm going to teach you this year organic chemistry, that is the chemistry paper 3rd. Now we are going to see, I will start the topic nucleophilic substitution reaction and saturated carbon. Before going to this, you must know what is a nucleophilic substitution or what is a nucleophile and what is a electrophile. These basic things you must know. Then see what is nucleophile. Nucleophile is a species which is electron rich in nature, while electrophile is a species which is electron deficient. Therefore, these are the basic things: nucleophile as well as electrophile. Now we'll see we are going to cover the many things in this chapter. Outline of the chapter is we will see, I will teach you the definition, mechanism of SN2, kinetics of SN2, important features of SN2, backside attack of the nucleophile, energy profile diagram. Also, we are going to see the stereochemistry of the SN2 reaction. After completing the SN2 reaction, we'll come to the SN1 mechanism, important features of it, energy profile diagram of SN1. Also, we will compare the SN1 and SN2 mechanism. Then we'll come to the factors affecting rate of SN1 and SN2. In this, one of the factor is role of the solvent in SN1 and SN2, which is very important. Therefore, that also we are going to cover. Now, in nucleophilic substitution reaction, you must know what is nucleophilic substitution. Therefore, it can be defined as it is a reaction in which stronger nucleophile replaces a weaker nucleophile. Therefore, the reaction between the substrate on that nucleophile will react. It gives the product and it gives the leaving group. The leaving group always leaves along with its bond pair of electron. Therefore, it is always having the negative charge. Now, in this case, you can see the nucleophile is Y negative. This will attack on the substrate. This is the substrate. On that carbon, the nucleophile attack from the back side. This leaving group X will leave along with its bond pair of electron. Therefore, overall reaction is in the product. This nucleophile Y gets substituted on carbon. Therefore, the nucleophile gets substituted on the substrate. This is the product. Therefore, nucleophile gets substituted. Hence, it is a nucleophilic substitution reaction. Simultaneously, this X will leave along with the bond pair of electron. Therefore, X having the negative charge, it acts as a leaving group here. Therefore, this is a nucleophilic substitution. There are many nucleophilic substitution reactions as SN1, SN2, and lastly, we will also discuss the SNI mechanism. Now, in SN1 mechanism, S stands for the substitution, N stands for the nucleophile, and 1 stands for the unimolecular. Now, in SN2, similarly, S stands for substitution, N stands for the nucleophile, and 2 stands for the bimolecular. This is depending on the order of reaction on the basis of kinetic study. 1 is unimolecular, 2 is bimolecular. Therefore, it is a SN2 is a second order reaction, while SN1 is a first order reaction. Now, actual mechanism taking place in SN2 mechanism, SN2 reaction, we are going to see that mechanism which is very important. Also, we are going to learn the kinetic study of it. Now, in this case, this is a CH3Cl, that is the substrate, means alkyl halide. It is written in a 3-dimensional way. Therefore, this is CH3Cl. Now, this is CH3Cbr. This is also CH3Cbr. That means the alkyl halide, which is a primary alkyl halide, is a substrate of SN2 mechanism. This OH negative is a nucleophile. This OH negative will attack from the backside on the carbon of the substrate. Therefore, the OH negative nucleophile will attack on the carbon of the CH3Cl. Then, simultaneously, this Cl will leave. And therefore, in the product, you are getting the nucleophile gets substituted. Cl will leave as a leaving group. Therefore, in product, starting material is methyl chloride. You are getting methyl alcohol as a product. But this reaction converted into product through the transition state. Therefore, in transition state, it is shown as whenever OH negative attack from the backside, the planar geometry of the CH3, therefore these three hydrogens are attached to the carbon simultaneously. The new bond is going to form between the OH and carbon, therefore it is shown by the dotted line. Simultaneously, this carbon and Cl bond breaks, therefore it is also shown by the dotted line. That means the new bond formation between carbon and OH, that is nucleophile, new bond between carbon and Cl is going to break, and this new bond is going to form between carbon and the nucleophile. That means bond formation and bond breaking takes place here simultaneously, and therefore it is shown by the dotted lines, while these three hydrogens are shown by the covalent bonds. This is the transition state. In this, the carbon is bonded with 5 groups, 3 hydrogens, 1 OH and 1 Cl. Therefore, total 5. Therefore, it is called as a transition state. It is a pentavalent which is very much crowded, very high energy is required. Therefore, it immediately breaks to give the product. Here also in 3-dimensional view, the picture gets clear. The OH negative, this oxygen of the OH, this OH gets attacked from the backside of the carbon. Then simultaneously CBr bond will break. Therefore, in transition state, 3 hydrogens, this new bond is going to form COH, and the bond will break CBr. Therefore, this is a transition state, pentavalent, very much crowded. You can see in 3-dimensional view. Therefore, immediately it will break to give the product. Here, the CH3Br. Now, one point, and Br will give as a living group. Now, one point I have to raise: whenever the OH negative approaches from the backside of the carbon, this molecule gets inverted. That means starting it is having like this. In product, it exactly get inverted. OH negative attack from backside, therefore OH comes here, and these 3 hydrogen gets inverted. Here also, whenever OH attack takes place, the OH will attack this side, therefore OH will join here, while these 3 hydrogens due to backside attack gets inverted in the product. Therefore, that is called as an inversion of the configuration. Here you can see here the blue color, that means OH negative attack from this on the carbon of the CH3Br. Then these 3 hydrogens gets along with carbon gets inverted. That means whole molecule gets inverted. Backside attack of OH, therefore OH comes from the backside and the hydrogen gets inverted. Therefore, whenever backside attack of the nucleophile takes place, the molecule gets inverted. Therefore, it is said to be the inversion of configuration. That again we will cover in the stereochemistry point of view in SN2. Now, whenever we study the kinetics of the SN2 reaction, as you know, the CH3Br is your starting material, OH negative is a nucleophile. Then it converted into the CH3OH as a product, just now as in, and Br will give as a Br negative. Therefore, overall reaction is like this. Previously, I showed in 3-dimensional view. This is a normal. Therefore, primary alkyl halide always reacts. SN2 will react on primary alkyl halide. Now here, the rate of reaction is directly proportional to concentration of the reactants. Here the reactants are concentration of the substrate CH3Br and concentration of the nucleophile OH. Therefore, rate of reaction depends on the concentration of the substrate molecule as well as concentration of the nucleophile. Hence, in the rate law, the 2 species are involved. Hence, it is a bimolecular reaction, and therefore it is referred as a second order kinetics. Now, there are some important features of SN2 mechanism. In SN2 mechanism, it is only one-step process, but it takes place through transition state. Then only one step is there, therefore that is itself is a rate determining step, which is a slow step. The kinetic study just now I discussed. Kinetic study shows that rate of reaction depends on concentration of this substrate as well as the concentration of the nucleophile. 2 species are involved in the rate law, hence it is a bimolecular reaction. Now students see, here it is called as a concerted type of reaction. Why concerted? Because the bond breaking and bond formation takes place simultaneously. Now here which bond breaks? Carbon and Br bond breaks, and which new bond is formed? Carbon and nucleophile COH bond will get formed. Therefore, bond breaking and bond formation takes place simultaneously.